We have long considered Mars as a potential second home. But the deeper we study our solar system, the more new candidates emerge, some of them perhaps even better for colonization. Life on Earth in its early stages was radically different from what it is today. The atmosphere was different, completely alien species dominated, and if we were to look at the landscapes that existed back then, we wouldn't recognize Earth as it is today. So perhaps, while we are hunting for potentially habitable celestial bodies, we should expand our criteria and contemplate the conditions that would foster the existence of alien life forms. And there's one world in our solar system that could fit these criteria. How is Titan the representation of the early Earth? What are these mysterious deserts on Saturn's largest moon, and what causes its lakes to erupt? Logo: Titan, diameter 3,200 miles/5,150 kilometers, the largest of Saturn's 146 moons. Is even larger than Mercury. But it's no ordinary satellite. The gigantic moon is so similar to Earth, it's almost hard to believe. Not only does Titan have lakes, seas, and rivers, but it also hides a subsurface ocean of water, 50 miles, 80 kilometers, below the icy ground. In the moon's skies, there are clouds, on its surface, organics. It rains on Titan, liquid bodies replenish lakes and seas, and then evaporate, launching an Earth-like hydrological cycle. The atmosphere of nitrogen and methane that envelopes the satellite is thick enough for you to safely stroll around its surface without a pressure suit. But that's only if Titan wasn't as cold as -290 degrees Fahrenheit -179 degrees Celsius and had an oxygen-nitrogen atmosphere like the Earth. And if you had wings attached to your suit, you could even fly as the moon's gravity is just 14% of the Earth's. Because of this, you will also witness rain falling in slow motion, about 6 times slower compared to Earth. Although it would be no ordinary rain. On Titan, it rains liquid methane, and it is roughly 50% larger than the raindrops we see on our planet. Titan is located some 750 million miles, 1,200,000,000 kilometers, from Earth, where it revolves around Saturn in about 16 days. Titan is tidally locked to the 6th planet. But even though one of its sides is always facing Saturn, the satellite still has intricate weather patterns. Saturn's largest moon receives 100 times less solar energy than our planet, and it has a thick atmosphere extending 10 times higher into space. In these conditions, not much light can get through and reach the surface. For the first half of Titan's day, which is equivalent to 16 Earth days, its surface is bathed in a faint orange haze. Looking through this haze would be like trying to see beyond thick fire smoke. The skies during this part of the day could be 100,000,000 times dimmer than here on our planet in an afternoon. And the other part of the day brings total darkness to the surface. But even if it was bright enough, you still wouldn't see Saturn from the surface of Titan because of the haze. Imagine standing on Titan, Saturn's largest moon, where the concept of day and night defies everything you know. Surprisingly, the brightest moments on this mysterious world aren't during the daytime but at twilight, when the sky glows up to 200 times brighter than the faint daytime haze. It's all thanks to the way light scatters through the thick, hazy particles in Titan's atmosphere, painting the horizon in a surreal, golden glow. Picture yourself gazing at this ethereal twilight, where the world seems to shimmer in a dreamlike radiance, as if the cosmos itself is whispering secrets. Titan, tidally locked to Saturn, has one side forever facing its ringed parent and another shrouded in eternal night, with a twilight zone, the terminator, marking the boundary between them. This borderland is a place of constant mystery, where light and shadow blur. Titan also experiences eclipses, lasting up to 6 hours, like a second night crashing into the middle of the day. If you stood on the Saturn-facing side, you'd witness Saturn briefly vanish behind the sun's shadow. On the night side, though, a solar eclipse would simply deepen the already inky darkness. These cosmic events aren't just spectacles. They help scientists unravel how much sunlight Titan's surface and atmosphere receive, shaping the conditions for any potential life forms that might call this moon home. Recent observations from the James Webb Space Telescope have unveiled another layer of Titan's charm, clouds forming in its lower atmosphere during late summer when the surface soaks up just a bit more warmth. Like Earth, Titan has seasons, tied to Saturn's tilt and lasting about 7 Earth years each. These slow, rhythmic shifts bring dramatic weather changes. Twice every 15 years, during Titan's equinox, when its axis is neither tilted toward nor away from the sun, day and night balance perfectly, splitting the moon into equal halves of light and dark. Have you ever pictured a world where colossal methane clouds gather at the equator, unleashing fierce windstorms that reshape the landscape? On Titan, this is reality. During the Cassini mission, scientists caught glimpses of waves rippling across Titan's methane lakes, waves unlike anything on Earth. Thanks to Titan's weak gravity, these waves tower 7 times taller than Earth's ocean waves but move in slow motion, up to 3 times slower, as if dancing to a cosmic rhythm. The winds on Titan don't stop there. They whip up powerful dust storms, scattering organic particles across the surface, much like the swirling dust clouds that rise in Earth's deserts or on the rusty plains of Mars. These storms paint Titan's surface with a fine layer of organic dust, adding to its alien allure. When rain does fall on Titan, it's no gentle drizzle. These rare but torrential methane downpours carve the landscape, leaving behind striking features called alluvial fans, triangular piles of sediment and ice, sculpted by flowing liquid. Imagine standing on Titan's surface, watching these mighty rains reshape the ground, creating patterns that tell the story of a world in constant transformation. Even more awe-inspiring are Titan's dune fields, sprawling across 13% of the moon's surface. These aren't your average sand dunes. They stretch hundreds of miles long, up to 2 kilometers wide, and rise 100 meters high, dwarfing Earth's dunes. But this sand isn't silicate like on our planet. It's a unique blend of organic compounds, hinting at the complex chemistry at play. What other secrets does Titan's ever-changing surface hold? How do these massive dunes and fleeting storms shape the moon's story? Let's turn to the next page to dive deeper into the mysteries of this enigmatic world, where the winds of Saturn's largest moon continue to sculpt a landscape unlike any other. Picture a world where the sand isn't like the gritty grains on Earth's beaches but instead a cascade of solid hydrocarbons, raining down from the sky like cosmic snowflakes. On Titan, Saturn's enigmatic moon, these peculiar particles form sprawling dunes that stretch across the landscape, shaping a terrain that feels both alien and strangely familiar. On Earth, landforms emerge through a simple dance. Rocks erode into tiny grains, winds sweep them into piles, and over time, they sculpt mountains and dunes. But on Titan, the story is far more mysterious, like a puzzle waiting to be solved. What makes Titan's dunes so baffling? Unlike Earth's durable silicate sands, Titan's grains are fragile, thought to be fleeting. Yet, they form massive, enduring dune fields that dominate 13% of the moon's surface. How do these delicate grains withstand the relentless winds to create such monumental structures? Scientists, peering into Titan's alien landscapes, uncovered a fascinating clue, a process called sintering. Here, neighboring grains collide with such force that they fuse into larger, sturdier clumps, resisting the wind's attempts to scatter them. Imagine tiny particles smashing together, forging resilient bonds to build dunes that stand tall against the cosmic gales. If Titan's sands can adapt to form such intricate landforms, could life itself have found a way to thrive in this alien world? Titan mirrors Earth in uncanny ways. Lakes, rivers, clouds, but its ingredients are wildly different. Where Earth has water, Titan flows with liquid methane and ethane, filling its clouds, rivers, and seas. Yet, this moon is far from dormant. Its surface hums with activity, as methane lakes stratify into layers based on density, much like Earth's oceans. Even more astonishing, these lakes can erupt in a frenzy of bubbles, driven by a volatile mix of methane, ethane, and nitrogen. Picture a lake on Titan suddenly bursting with bubbles, reshaping river deltas in a spectacle of raw, alien power. These bubbling lakes aren't just a curiosity, they hold clues to Titan's complex chemistry. Imagine a future submarine gliding through Titan's methane seas, its heat triggering an explosive cascade of bubbles, like champagne fizzing over. Such discoveries highlight not only the dynamic nature of Titan's liquid bodies but also the challenges awaiting any spacecraft daring to explore these strange waters. Could life exist in such a place? If it does, it would be unlike anything we've ever seen, with a biology as foreign as the moon itself. Researchers from Cornell University have sparked intrigue by suggesting that cell membranes, crucial for life, could form in Titan's harsh conditions. On Earth, these membranes are built from phospholipids, molecules with a polar head that loves water and a neutral tail that shies away. Picture them as a sandwich in water, the heads face outward, embracing the liquid, while the tails huddle inward, shielded from it. On Titan, could similar structures arise in methane instead of water? The possibility is tantalizing, hinting at life forms that might defy our wildest imaginations. What other wonders lie hidden in Titan's icy depths and shifting sands? Could this distant moon hold the key to understanding life beyond Earth? Let's turn to the next page to explore the tantalizing possibilities of Titan's chemistry and the mysteries that await in its strange, vibrant war. Imagine a world where the building blocks of life twist the rules we know. On Earth, cell membranes form like a perfectly crafted sandwich. Phospholipid molecules with polar heads that love water face outward, while their neutral tails shy away, hiding in the middle. This elegant structure gives membranes the flexibility crucial for life, bending and adapting to keep cells alive. But on Titan, Saturn's largest moon, the game changes. Could life find a way to thrive in a place where liquid methane, not water, rules the surface? The answer lies in a chemistry as strange and wondrous as Titan itself. Methane, unlike water, has an even distribution of electrical charges, making it a nonpolar liquid that challenges Earth-like membrane formation. Titan's frigid lakes, plunging to -179 degrees Celsius, lack the phosphorus and oxygen needed for our phospholipids. Yet, scientists have glimpsed hope in the lab, crafting inside-out membranes in nonpolar liquids like methane. These Titanian membranes would need to be built from something entirely different, molecules tough enough to withstand the moon's icy, alien environment. What could these molecules be? Titan's atmosphere, a swirling mix of methane and nitrogen, holds traces of exotic compounds, offering tantalizing clues. Enter acrylonitrile, a molecule detected by the Cassini mission in Titan's hazy skies at about 10 parts per million. Computer models suggest this compound could form stable, flexible membranes in methane lakes, mirroring the resilience of Earth's cell walls despite the vast temperature gap. Picture these membranes forming in Titan's shimmering lakes, standing firm against the cold and the currents, like delicate shields for hypothetical life forms. This discovery flips our understanding of habitability upside down. Instead of hunting only for Earth-like planets in the habitable zone, where liquid water flows, we might now search for methane-based life on distant, frosty worlds. The implications are staggering. Across our galaxy, the number of worlds that could harbor alien life could explode, from icy moons to far-flung planets where methane runs like rivers. If life on these worlds has evolved over eons, could we encounter complex organisms straight out of a sci-fi saga, creatures as fantastical as those in our wildest stories? Even if Titan's surface proves too harsh for life today, a hidden ocean of liquid water lies beneath its icy crust, a secret world waiting to be explored. Scientists are racing to understand whether organic molecules from Titan's surface can seep through this icy shell into the subsurface ocean. Could this hidden sea, shrouded in mystery, be a cradle for life? We don't yet know its density, composition, or temperature, nor how it interacts with the frozen crust above. One critical question looms: is there a source of chemical energy down there to fuel metabolism? Remarkably, a rare Earth bacterium with a unique metabolism offers a clue. It could potentially survive in Titan's deep ocean, hinting at possibilities we've only begun to imagine. Billions of years ago, Earth's atmosphere was a chaotic brew of nitrogen, carbon dioxide, and water vapor, raining down to spark the cycle of life. Titan's chemical makeup today echoes that ancient Earth, making it a living laboratory for studying life's origins. What secrets does this moon hold about the dawn of existence? Could its frozen surface and hidden oceans unlock the mysteries of life across the cosmos? Let's turn to the next page to dive deeper into Titan's potential as a cradle for alien life and the cosmic questions it inspires. Imagine a moon so distant, yet so eerily familiar, that it might hold the key to unraveling the mystery of life's beginnings. Titan, Saturn's largest satellite, is like a time machine, its surface brimming with the same chemical ingredients, nitrogen, methane, and organic compounds, that once sparked life on a young Earth billions of years ago. Astrobiologists gaze at this alien world with wonder, seeing in its hazy skies and methane lakes a mirror of our planet's primordial past. Could Titan be whispering clues about how life first stirred in Earth's ancient oceans? Perhaps, in some distant future, millions or even billions of years from now, this icy moon could evolve into a vibrant, habitable world, teeming with organisms that resemble Earth's own. The answers to these cosmic questions may be closer than we think. In June 2027, NASA's Dragonfly mission, a daring robotic helicopter, will take flight toward Titan, soaring through its thick atmosphere to hunt for signs of life. Picture this ingenious craft weaving above Titan's dunes and lakes, probing for water or hydrocarbon biosignatures that could hint at life's presence. With every hop across the moon's surface, Dragonfly aims to unlock the secrets of Titan's hidden subsurface ocean, a vast, mysterious sea locked beneath its icy crust. Could this ocean harbor the conditions for life? Scientists are on the edge of their seats, eager to discover whether Titan's chemistry holds the ingredients for life as we know it, or something entirely new. If alien life exists on Titan, what might it look like? Picture creatures sculpted by methane, with biology so strange it defies our imagination. Perhaps shimmering, translucent forms drifting through liquid lakes or thriving in the depths of that hidden ocean. What do you think these otherworldly beings could be? Drop your wildest ideas in the comments below, and let's dream together about the possibilities. As Dragonfly prepares to embark on its epic journey, we're standing on the brink of thrilling discoveries that could reshape our understanding of life in the universe. What lies in wait for us on Titan's frozen plains and beneath its icy shell? Could this distant moon hold the spark of life, or even a glimpse of our own origins? Stay tuned as we venture to the next page, where the mysteries of Titan's potential and the future of exploration await.